Hi students, let us begin the series of videos for Analog Electronic Circuits Lab. In this first video, we shall see an introduction to Analog Discovery version 2, which is an NI edition. Usually, we'll first have a look at what are the requirements to conduct experiments. So, we need to have a power supply, signal generator, oscilloscope, of course the components, and we may need to have some network analyzer, so that too for very high-end experiments which will be there in the research and development labs. So these are the basic things that are required to conduct any experiment, when it is whether it is a very simple resistor potential divider, or it can be a complicated FMD modulation. Now we will have a look at how do we use this Analog Discovery version 2, which is an NI edition. This is how an Analog Discovery will look like, which is basically a product of Vigilant. Now they have made it for compatible to National Instruments. If you can have a close look into the features of Analog Discovery version 2, let us go pin by pin. So as you can see, this is 1 plus, which is actually a scope channel 1, which is a positive, which will be having a color orange. Similarly, we're going to have the negative of the same scope channel 1, which is orange with a white strip. Similarly, for scope channel 2, blue is the color, as you can see here, and 2 minus will be blue with a white strip. Now these are all the colors of the wire which are there existing in the real circuit. And of course, wherever you see this black, it corresponds to ground. So we have actually 4 black wires which will be used for circuit connection. This Analog Discovery has got option of providing the supply voltage, which is 5 volt DC, which will be coming from this red colored wire here, and we'll get a minus 5 volt from this white wire. And we have 2 signal generators, namely waveform generator 1, which is yellow in color, and we have waveform generator 2, which is yellow with a white strip. And again we have some trigger 1, trigger 2, which are not very essential at this level of experiments. And we have 16 digital IO pins. We have pink, green, purple and brown, and that pink, green, purple and brown will repeat with its position, and we have its white strip around it, which is representing another 8 wires. So we ultimately have 16 digital IO pins, along with oscilloscope with 2 channels, that is channel 1 and channel 2, and we have power supply with plus 5 volt and minus 5 volt, and we have 2 waveform generators, namely this waveform generator 1 and waveform generator 2, which is yellow in color, and we have 4 ground lines, ground wires available. Now, as we already saw, so the oscilloscope, which is 1 plus 1 minus and 2 plus 2 minus, is capable of measuring plus or minus 50 volt differential or 25 volt single-ended voltages, and WaveGen, which is identified by W1, W2, can give a maximum amplitude of plus or minus 5 volt with a current supply of almost 10 milliamperes. And the power supplies can vary from 0.5 to 5, both in plus and minus. The maximum voltage you can get is plus 5 and minus 5. You can see if it is USB powered, we're going to have a current of 700 milliampere per channel, or maximum 500 milliwatts of power you can get if it is USB powered. Suppose if you have an auxiliary power supply that is connected, you can go up to a power of 2.1 watt per channel. So this is the amount of power this Analog Discovery can deliver. May not be a great amount of power, but that is sufficient to do any of our experiments. Coming to digital I/O, so it has got 16 digital I/O pins and it can give a digital high of 3.3 volt, and each line can give a current of 4 milliamperes. So this is more or less sufficient to conduct any experiments that are there in uh, second year and third year of our bachelor degree of engineering. So let us go to the details of it. Okay, how do we use this unlock discovery? So use this unlock discovery, we need to install waveform 2015. This is how it looks, okay, upon installing waveform, and if you invoke it, we can see actually you can have a scope which is exactly an oscilloscope which has got two channels, and we have got this wave gen, which is a wave generator, and we have got supplies which can give plus and minus 5 volts, and we have got a voltmeter, and we have got logic analyzer, we have got pattern generators, we have got static IOs. So we'll go one by one and try to find out what is the features or what are the advantages and how do we use each one of the uh, capabilities of this unlock discovery, which is there coming through this waveforms 2015. So let us start connecting this unlock discovery through waveforms, and let us have of course let us have again a close look into, okay, what are the different options. As I said, it is scope, wave gen, we have supplies. These are the three major things which we'll be using, along with if you are doing any digital experiments, you'll certainly use this static I/O very often. So let us see a demo of unlock discovery. How do we use this unlock discovery for conducting any experiment? So what I'll do now is let me select this waveform. It has been selected. Now you can see, let me just make it wider. So it has got a scope. If I double click on a scope, I'll get uh, the oscilloscope coming up. You can see this is oscilloscope, and you got of course now this is not running. So if I say run, it will acquire the data which is coming on channel 1 and channel 2. Now since I not connected anything to channel 1 and channel 2, you can see both the signals are 0. And as you can see now, oscilloscope is one which is used to measure the amplitude, measure the frequency, and measure so many parameters. Those can be adjusted over here. So you can see we got time. You can set whatever the time base is, which can be set as per user requirement. You can just click on this, and then you're going to have the selection here. So ranges from very maybe 1 millihertz to almost 10 megahertz is the maximum frequency you can measure. And you can also change the volt per division, which is on the y-axis. So you can go from 5 volt per division to all the way down up to microvolt per division. As you can see here, it is almost zero point 0.1 millivolt per division, which is 100 microvolt per division. And you can also adjust the offset over here, which can be set from any of them. You can either select from this, or you can just edit it directly onto the options available. So let us try to generate some signal from unlock discovery and try to display it on scope. So let me just select this wavegen. I have selected wavegen now. So now we can see this has got actually two channels, as we discussed in the previous slides. So now you can see only one channel is coming. I can actually select both the channels. So you can select uh, second channel, so you can see now it is coming. Maybe what we can do is we can take only one channel and then start analyzing how do we set the values. Now as you can see, this is a wave gen, which is a waveform generator. It has got the capability of giving a DC signal, a sine wave, a square wave, triangular waveform, ramp up, ramp down. It can even generate noise, a trapezium waveform, and it can also generate a power waveform. Let us go to each one of them and try to find out what are the features that are possible in fixing this. So if you select DC, suppose now if I selected DC, now you don't have too many options. You can actually set the desired DC voltage, which ranges from -5 to +5 volts. So you can select whatever value you want. Suppose if you say if it is 0.2, now we can see you're getting 0.2 volts. Suppose if I say run, so I'll be getting 0.2 volts coming from waveform 1 channel, that is the yellow wire of the unlock discovery. Suppose if I connect yellow wire of the unlock discovery to the orange wire, which is the scope 1 of unlock discovery, I'll be getting actually zero point 0.2 volts will be displayed on the scope. Now you can see it is now running. 0.2 volts is actually coming out from waveform 1, and the same is now connected to scope 1. You can see now you can certainly see this is slightly gone above. Now what I'll do is let me make this channel 1 range as zero point 0.1 volt per division, which will make my output waveform. Okay, over here you can see now I actually applied an input voltage of 200 millivolts, that is coming from waveform 1, that is now connected to scope 1. You can see it's exactly 200 millivolt DC voltage coming. So what you can do is you can take out this waveform from this palette, and you can simultaneously see both of them. What I'll do is I'll just put this waveform on this half of the screen. I'll put this oscilloscope on the other half of the screen. Now I'll make it, let me make it maybe 0.5 volt. You can see as soon as I make it 0.5, this increases to 0.5. You can see when we made it 0.5, now the output are in scope 1. I'm seeing 500 millivolts. Suppose if I make this as 2 volt, now let me just edit this as and make this as 2 volt. Now you can see I'm unable to see it here because this range what I've selected is not proper. It can since it is chosen as 0.1 volt per division, so you could able to see only 500 millivolt. Since the voltage that is applied to scope 1 is 2 volt, I have to change this volt per division to a suitable value. Now you can see it is 1 volt per division. Actually you have 5 divisions over here on the above half, and you have another 5 divisions on the below half. So now we can see applied voltage is 2 volt. You are measuring 2 volt here, so this is exactly 2 volt. You can actually go to use this many options available in unlock discovery for making the measurements. So what I can do is I can actually see what is the voltage level. So go to this view and then this measure, click on measure. What I'll do is let me just make it now. Let me measure the voltage. You go to view option. In this view option I have got this measure. Now I can add the parameters. It's a defined measurement which is already defined here. Now let me measure channel 1 vertical parameter. In this vertical parameter I can measure so many parameters. I can measure maximum voltage, minimum voltage, average, peak to peak, high, low, whatever. So let me measure what is the maximum voltage I have. So if you double click on this maximum, you actually get the voltage that will get added here. Now you can see it is 1.993997 volts, which is approximately 2 volts. So this way we can able to actually measure the voltage and it will be displayed over here. So I can comfort